Our next speaker is Callie Flynn, lead data scientist at General Mills. Her presentation today will be called Beyond Tokens and Pixels, using embeddings to unlock consumer insights. We'll hear from Callie for about 20 minutes, and then we will have 15 minutes for Q&A session. There are folks online, so if you are raising your hand to ask a question, wait for the microphone so that we can be sure that everybody can hear and participate. Thank you. Welcome, Callie.
Hi everyone, I'm Callie Flynn, and I'm super excited to talk to you guys about embeddings today. Do I need to stay close to the mic? Okay, sorry. I'm a bit of a pacer when I talk, so thank you to the brave souls who will just keep me on track back there. So first off, just to level set, I know we probably have different levels of familiarity with embeddings in the room, but all of an embedding is just a representation of data. And a lot of times that means taking a large amount of data and shrinking it down into something that still retains its meaning. And I think a really good analogy for this is basically how we text all of the time, right? I don't think anybody out there is actually typing the words laugh out loud when they're texting with some of their friends, right? We've learned this encoding, this embedding, if you will, that LOL, it means the same thing as laugh out loud. And of course, algorithmically, algorithms don't think in terms of letters or words, right? And so an algorithm might actually map the words laugh out loud to the numbers 5 and 7. Still going to retain its meaning here, right? So pretty happy, pretty high volume. That's it. Embeddings seem relatively straightforward. But the cool thing about embeddings is that when we are able to take things that previously we weren't able to translate into an understanding that an algorithm could get, we get some really, really amazing, powerful things that are coming from this. The reason that I'm talking to you about embeddings today is because they power today's heavy hitters in the AI space, right? Anything to do in the NLP realm, chatbots, ChatGPT, that's all based on the concept of mapping words to this vector of numbers. That's all an embedding is, a vector of numbers. Same when we're talking about images, for example, right? When we're thinking about Gen AI, that's all possible because we are able to take pixels of images, so a piece of a picture, and map that into a string of numbers in embedding. And I think it's really easy when we see stuff like this to say, that's really cool for people that have lots and lots of images. I don't have that in my work. That's cool for them. I hope maybe someday I can work in that industry. I think it's really easy to say, I don't have a ton of text data streaming in. I don't have like call center logs. I'm not Twitter. I'm not Meta. I don't have a ton of text data. And what I really hope that you take from my talk today is that I can sort of give you some encouragement that all embeddings are is a piece of technology. And when we really harness the power of technology and apply it in a different use case than what was originally invented in, that's where you start getting a competitive advantage. And so I have a couple examples on the screen. Both the microwave and the GPS were actually invented by the military to track enemy movements. Of course, today we use microwaves to heat up our food, right? And GPS to find where the nearest target is. And so what I really hope you take from my talk is that if you are in an area where you don't have access to text data or image data, embeddings can still apply in your particular industry. And so I want to give you a couple of examples of how General Mills is using embeddings on tabular data. This is not on image data. This is not on text data, to better understand our stores, products, and consumers. So first up, let's talk about stores. As General Mills, it's really, really helpful for us to understand where you're primarily sourcing your products from. This really helps us get a good understanding of the consumer, how they're using that product, and maybe how we want to position that product with them. So let's take Chex Mix, for example. If you are primarily buying Chex Mix at Target and Walmart, you are probably pre-planning that trip. You're probably buying a large size of that particular bag, right? If we are maybe knowing that that's where you primarily shop, we're probably going to position Chex Mix as something that is kind of a crowd-pleasing, maybe a game day appetizer type snack. Contrast that with if you are primarily purchasing Chex Mix at a convenience store, you're probably buying a small individual package there, right? And so we probably want to position or maybe even craft products for you that could fit in the cup holder of your car, right? We're going to talk about how this is a craveable on-the-go snack. So algorithmically, kind of the two choices that we've primarily had as data scientists to use this type of information, this store name, which I realize is a text data, right? But typically that would be in a tabular data set, and it's just, it's text information. And so two ways that we could primarily use this. We could, one, condense everything down into a store category. We'd say, hey, Target and Walmart, you are mass merchandisers. Hey, ConocoPhillips and whatever gas station you choose to shop at, those are convenience stores, right? But what we have here is a loss of information. We know that Target and Walmart are similar, but they're not the same. And the same with all of our convenience stores. And so this is kind of tricky. We're losing information in this particular instance. The other option, which is popular on blogs, you'll probably see this a lot, right, is one-hot encoding. And that is the ability where you would just take Target. You would say if you shop at Target, you get a 1, and all of the other stores, you get a 0. This works when you only have a small number of stores. But what happens, right, is General Mills sells our products at thousands and thousands of stores. And so when I start adding thousands and thousands of stores on here, that one ends up getting lost in this sea of zeros. And it's also very hard for the algorithm to determine that Target and Walmart actually have some similarities. This is a really sparse data set, right? You're probably familiar with that term. So this is where embeddings can really, really shine. Here's an example of a way that we have conceptualized building a store embedding, right? Embeddings let you have the nuance of things can be different, but they can be similar. And so one way that you could build a store embedding for Target, for Walmart, is you could take a neural network and you could train it. Embeddings are oftentimes an example of transfer learning. I'm going to train this neural network to predict store category. So I'm going to predict that Target is a mass merchandising store, that Walmart is a mass merchandising store. I'm actually going to throw away that prediction. That's how a transfer learning works, right? An embedding is typically a layer in a neural network. And so I'll have trained this particular network to predict store category. I'm going to throw away that prediction and extract the store embedding from one of the neural network layers. If you're familiar with neural networks, of course, all of those layers, they're just numbers, they're weights, right? So that's that 5 and 7, that mapping. And when we're able to do that, we, of course, get kind of these magical looking graphs. This is definitely an oversimplification. This is a 2D representation of our store embeddings, right? But you can kind of see Target and Walmart, they're kind of in the pink up there. They're similar, their dots are similar on the graph. They're kind of near neighbors, but they're not the same. Same with our grocery stores and our dollar stores and our convenience stores. And so again, this helps us sort of precede our algorithms with the understanding of what does it mean to shop at Target. This also helps us, of course, with things like mass customization. General Mills is going to customize product mix for stores, right? If we have thousands and thousands of stores, that's an impossible job for somebody to do. But this enables us to start to do mass personalization. So that's an example of how we're using store embeddings. Next, let's move on to product. I'm going to start off with an example of Leap and Lemurs, which is actually not a General Mills cereal, so please don't tell my boss it's not this presentation, but it's really good for this example. Leap and Lemurs is a cereal. It is like Captain Crunch. It is like Frosted Flakes or Lucky Charms. But it's also one of those weird cereals. Sometimes it's in that aisle where it's kind of referred to as the natural aisle, if you will. You probably know what I'm talking about. They typically have like bulk granola, bottles of vitamins. It's that natural kind of aisle. And so when you are designing your custom embeddings, you get to pick what kind of information you are going to precede the algorithm with. And so if you're Target, for example, you might look at something like Leap and Lemurs and say, I need to make sure that it embeds close to the other cereals because it is a cereal. And so when somebody searches that word, they're going to want Leap and Lemurs to come up there. If I'm somebody like Shipt or Instacart, I actually don't want Leap and Lemurs to be very close graphically, if you will, on that embedding to things like Reese's Puff or Lucky Charms, because I'm going to send somebody to the wrong aisle as I'm designing how they shop through the store. So at General Mills, one way that we're thinking about product embeddings is actually much more similar to this in the natural aisle way. We want to know what products group together. It's kind of like a fashion sense for food. So let me just give a quick diversion because I think this analogy is helpful. So if I were to know if I were to look into your closet, if I'm a clothing retailer, and I look into your closet and I see what do you have, what do you purchase over and over and over again, I get a sense of your fashion sense, right? Person's closet on the left is a little more preppy. Person's closet on the right is a little more edgy, a little more bold. So if I'm a clothing retailer and I have something like a blue Oxford shirt and I want to be able to market that, I know what market I'm going to play in, right? I'm probably going to play in kind of that preppy and classic market. Being able to understand where your product plays, what kind of sense it has in the market is really, really helpful. One, it helps us size the volume of that market. Two, it helps us create products that really resonate with the consumers that we're going after. So how does this relate back to food? Purchase style is kind of how we conceptualize. If I were to look in your pantry, in your refrigerator, and see what you purchase over and over and over again, right? I'm going to get a sense of your food fashion sense, if you will, your purchase style. So the way, before I get kind of to the results, the way that we've conceptualized this is like a large language model. We're using your purchase habits like sentences. Again, this is kind of text data, but it's not like sentences that you're sending back and forth to somebody. So we're taking all of the different purchases that Jill makes consistently over the year, what she's stocking her pantry with, and the same with Henry here. We're feeding that to a large language model, and we're able to get out these word embeddings, but they're actually product embeddings, right? So you'll see kind of some of our General Mills products up here. That helps us, again, draw kind of that circle around them for us to better understand where should we position this product in the market? Who am I appealing to? How can I best position my brand with this group of consumers? Here's some real purchase styles that we get from our embeddings. Totino's pizza rolls, for example, embed really close to things like Uncrustables, State Fair, Tyson chicken nuggets. This helps us say, hey, this consumer is probably after something that's convenient, that's tasty, that's on the go. Contrast that with our consumers who are primarily stocking their pantries with Pillsbury pie crust. You see a very different picture here, right? This is a homemade, hearty, memory-making type of individual. So finally, I want to end with how we are embedding our actual consumers, the people that purchase our products. I think by now in the presentation, you've kind of gotten the idea that embeddings are really helpful when you have lots and lots of data and you're trying to figure out what is similar but not quite the same. Consumer embeddings help us answer questions like, who's value-driven? Who's the most valuable? Who are we really honing in with and have the right to win with our product offerings? And who are our product offerings potentially really missing? One other way that you can design embeddings is by using a neural network called autoencoders. This is kind of a fun neural network. You actually would take like all 1,000 data points about that consumer. That's your input. That's also your output, your predicted target. It kind of works like a compression algorithm, right? And so if you've ever used a zip file, right, maybe you have professional photos and you have these huge images and they can't fit on your computer. So you're gonna zip that file and then there's some kind of an algorithm key, right, that like blows that back up. Same intuition here. I'm training a network to predict what's in the network. And I extract that middle layer typically, and that's my string of numbers, my embeddings. Here's some ways that we're using that. Let's say we take all of our consumer embeddings and we overlay, we color code our top Pillsbury buyers on here. You can already see that there's a dense area on the graph. We're seeing, hey, they actually have really, really similar purchase patterns. We can use that and we can say if we want to start to expand who is purchasing Pillsbury, we might expand to these blue dots that are really close to nearest neighbors. We think they're close to their tipping point. They already show all the right behaviors, so we should probably market to that particular group. If we do market and we have a big budget, we probably actually really have 3 distinct groups that we should be going after. And then finally, when we start to look at kind of exploring what else we could do with consumer embeddings, this one is one of my favorites. We can start to look at, hey, Pillsbury is not reaching this entire sea of people, but yet there's a couple of orange dots in there. I'm trying to see if you can see them. You can kind of see them in there, right? Those are people that are top Pillsbury buyers that don't look like everybody else who buys Pillsbury. They can give us some really good insight into, hey, if we want to expand the brand, let's look at these people as potential kind of archetypes, muses, right, to potentially expand our brand. So with that, I have plenty of time for questions, I think. Thanks for your attention. Right here. I think they want you to use the microphone for folks online.
I have a quick question on the product part of your talk.
Yep.
So you were talking about how you're using product to determine like kind of personas of who's making these purchases. How do you tailor your, I guess, marketing or your product toward these specific kinds of buyers? I'm wondering, when you do that kind of representation learning, are you including more variables than just the products themselves? For example, like what kind of people are buying this, and what kind of feature engineering are you doing from behind the scenes to, so we see kind of the graphical representation of the embedding, but I'm just wondering, like, how is that, how are those representations generated, and do you run the risk of, the curse of multidimensionality, like flooding the zone with too many variables?
Fair question. So we actually train these product embeddings literally only using the products themselves, but how it would look, like if you typically buy Diet Coke and I buy Diet Coke, then there's 2 samples in my training set that would have Diet Coke. They're trained like using typically something like a word to vec, where you're just looking at kind of a co-occurrence of how things are working. To your question about do we consider other variables, typically we'd use this embedding alongside other variables in our predictive models. But it is helpful at times for our brand teams to show them things like this, because I think it can be helpful when we're trying to think about, like, hey, is Tyson a competitor to Totino's Pizza Rolls, or is it a complement? So there's some questions that we can take back to the brand teams like that. Does that help?
Yeah.
Okay. Right there, sorry. And then we'll come back to the middle. So if you want to go first.
Yeah, absolutely. I love the presentation. I really was thinking about the part in the beginning where you're talking about positioning in the store, and especially with the contrast between an Instacart shopper versus a regular consumer, and how does that affect positioning, because those are operating off of 2 very different kind of concepts. One person is going in there with a set list, and they can't particularly deviate from the other person's there, and has the ability to make decisions on the fly of what they're purchasing. So how does that impact kind of how you look at positioning in a store?
Yeah, you mean like actual shelf positioning, or like with our marketing?
Yeah, with marketing too, because if an Instacart person can't decide to pick a competitor's product, or they have to get exactly what's on the list. So
yeah, I see what you're saying. That's a fair point. So yeah, that's where we use, typically we'll put as an input into our models where people shop, but sometimes, like what you're talking about, we'll actually use it on a filter on top of our model scores, and we'll say this is kind of the Instacart bucket, and this is the Target shop themselves bucket. So good question. I would say sometimes we actually use things as a filter.
yeah, awesome. Thank you.
Okay,
Hi.
back in the middle.
Yeah, I actually have 2 questions. First thing is, how would you handle cold start problem? Like if you have a new product, or if you have, let's say when you do consumer embedding, I'm assuming, let's say you are looking back for, let's say 1 month, 2 month historical data, but what if they are new customers? They just shopped once, for example. So that's the first question. Second question is, I see that it sounds like the input is the name of the products. So how would you compare using the names itself rather than the ID, for example, ID of the product?
Yep.
especially when we have a large number of products?
Yeah, good question. So the cold start question, we're lucky we don't actually have to deal with that a lot at General Mills, primarily because we don't actually make individualized recommendations. What we often will use our consumer embeddings for are like bulk segmentations or recommendations to our brand team. And so we actually just wait until we have enough information on a consumer to add them into it. So we're lucky I can kind of like dodge that question. The second question, oh, you were asking, do we use this product name or do we use an ID? We actually typically use an ID, but we've actually built this at several different levels. So sometimes you might want to know down to the individual like product size, so like a Diet Coke 12 pack, that'd be like a UPC or a SKU level. Sometimes we've also built these like at just the Diet Coke brand level, and it depends on the level of marketing or consumer segmentation that we're trying to go for. So if we want to be more high level, I actually would just probably have Pampers here. If we want to be more low level, I would use the SKU level kind of ID for Pampers.
I see, thank you.
Yeah. Okay, there's one in the back and then there's one up here, I think. I'm trying, doing my best.
So when it comes to identifying new audiences, how is General Mills able to target those audiences? Is it through like Google search or through like deploying prospect advertisements, or how does it do it?
Multiple ways, I would say. So we're on kind of all of your paid media platforms. So we're on like Meta, we're on TV commercials, we're on Spotify. And depending on how those particular platforms work is kind of how we do the targeting through them.
Great, thank you.
Okay, question up here.
Yeah, I think a nice talk today. I learned a lot. I'm a statistics professor at University of Minnesota, also DSI core member. My suggestion is I use the neural network model for forecasting the stock price many times, but it's already failed. So prediction is by using neural network model, maybe not reliable sometimes. But my suggestion, now that I'm doing more financial time series, volatility, so risk management, volatility. So you use volatility for classification, high risk, low risk group, then maybe you can do sort to make grouping based on the risk. I think that's my suggestion. I think more reliable result, volatility.
Fair suggestion. I would say one thing that's really also a little bit nice about again being able to dodge some of the questions is because we don't operate kind of on the low level individual. We're looking for directionality in our data set. Some of that volatility we're a little less concerned about at times as well. So, yeah. Okay.
Question from online.
Okay, great.
It says, can you elaborate on how you actually collect the data? Is it just based on online shopping or in-store shopping combined?
It's both. General Mills obviously sells our products to stores. Those are actually our customers. That's why you'll probably see on my graphs I say like consumers. But a lot of times we're able to partner with third-party data providers to get that individual kind of store-level transactional data. Okay, I think you had a question, and then behind you.
So this information is obviously used for marketing. Do you ever use it to decide what new products to develop?
Yes, we are working on that arena. So this, I would say, is a really good use case where you could use it for top funnel marketing, so like building familiarity with your brand, but then also developing new products and deciding if you want to push your brand into this direction or maybe create a new brand that's kind of under the General Mills family umbrella. So yeah, we do. Okay, question.
Hi.
I'm wondering, do you keep this mostly internal, or do you share these insights with like the retailers? So if you're looking at like a Target, for example, as a Target employee, are you sharing those insights with them about like kind of positioning or different marketing efforts?
It's a really good question. For the most part, internal, but we do have cases where we do work kind of with the retailers. It's kind of an interesting spot to be at times, right? Because General Mills does actually compete against like a Target branded product, a Kroger branded product, but we do have some mechanisms for collaboration too.
For your embeddings, do you normally keep it to like say 2 dimensions, or do you often use like high dimensional embeddings for your actual analyses? And if so, then how do you sort of visualize and get a more intuitive sense of very high dimensional embeddings?
Yeah, so I would say all of these that you've seen on the screen, it's typically a TSNE or a principal components analysis of a representation of the embeddings, but they're all pretty high dimensional, multiples of bits, right? So a lot of times like 128 or 64 would be a really common way that we've embedded, and then we try our best to represent them graphically, but this is definitely a place where I feel like we need a lot more work in the data science community. It's really hard to visualize embeddings and get business partners, right, to be really comfortable with that. So, but yeah, typically very high dimension, but not super high, in the hundreds.
Well, thanks.
Awesome. I think we've exhausted the questions. Anybody want a final one? Okay, we got one guy who wants a final one. Brave soul, I like you.
Yeah, sorry, hold you a little later. So I see how this can be used. This is great for determining which customers you might be missing out on, or product or customer segments, what have you. Do you take it to, I'm not sure if you call this one step further or one step to the side, trying to analyze how much you will be selling, like the extent of sales, perhaps if you capture a greater percentage of the market?
Yeah, I think eventually we would like to get to the place where you could imagine, instead of having these be top buyers, we have things like most valuable consumers, and we might say, are we hitting the most valuable consumers for our umbrella of brands with the right kind of products? Do we need to develop more products? Should we maybe cut back in some of our ways?
Gotcha. So
Yeah.
sorry if I could follow up. So
Yeah.
so business value in terms of sales, is that a component of what you are analyzing or using to, kind of defend the work that you are doing?
It depends on the use case, but yes. So like our consumer embeddings, right, on autoencoder, and so we're using all the input data as the target, but you'll see other instances where we actually won't use an autoencoder for the consumer embeddings. We would use something like lifetime value. So yes, to your question. Yeah. Okay, thank you guys for all the engagement and the questions.